Hello everybody, hope you're doing well. My name is Mahmoud Kiosari and this is Special K. So today we are going to move on into another subject. Like the previous videos that you can some kind of look at through the YouTube channel, we were talking about four basic arithmetic operations. So right now we are trying to dive a little bit inside the topic itself, and we are going to start the work with the fractions. Okay, we came back with the chapter 2. The funny thing that happened to me is that I was just trying to record the whole video without my mic was on. So, oh my god, that was so bizarre. But anyways, that's a good thing because right now at least we do have all of the writings that we have, so we can start from the beginning. Okay, cool. So we finished the part about the reducing the fractions into the lowest terms, and right now we are trying to talk about some kind of the exercises that how we can do that. So at this point, the good thing about this kind of questions right now is that they're giving you some hints. Why? Because maybe some of you would say that, okay, I do have a fraction, for example, 15 by 25, and I don't have that much of an idea that how I can find a number to divide both of the numerator and denominator by them, and after that I do have the lower or the lowest terms. At this kind of question, they're actually giving you some hint, and they would say that, okay, I do have a 15 divided by 20. I need you to convert it to fourth. What does that mean? Convert it to a fraction that the denominator is 4. Easy, simple, right? So I do have 15 by 20. And after that, what do I have? I do have a division by a number. Again, it's unknown, I don't know, but I know that these two numbers should be the same. Doesn't matter what number I use. The number that I use, my denominator should be the same as denominator. What is the final answer? The final answer should have four in it. So obviously, what is the number that should be divided by? What is the number that I have to divide the 20 by that in order to reach to 4? Obviously it's 5, right? Use the same 5 over here. 3 over 4, and that is my final answer. The way that we do have it over here, we do have a 36 by 40, and I need to convert it to 10th. Right? Now, what does that mean? Again, it means that convert the 36 divided by 40 to a number or to a fraction that has tenths in its denominator. Simple. So 40 is 4 divided by 4, obviously, is going to give you 10. 36 divided by 4 is going to give you 9. That's it, 9 over 10. I believe you also can do all of these fractions by the way that I just told you. Remember, look at the question. The question is giving you hint about the denominator itself. So by using that part, by using that hint, you can convert your denominator, you can find a number to convert that denominator, and also you can use the same number for your numerator, and that's it. Bam! So let's look at the question that actually we don't have any hint about that. So there are sometimes that the question would say to you that, hey, convert this fraction to the lowest term. So at this point, you don't know. It's 10th, it's 4th, it's 5th. What is that? So at this point, I can give you some kind of small hint about that. 6 divided by 10. Try to find a number that can be divided, or if you divide the big number by them, you don't have any remainder. 6, it contains 2 and 3. 10 contains 2 and 5. So what is the common number between these two? Exactly, that is 2. 2, 2, 3 by 5. Bam, that's it. Can I do more? Obviously not. There's no number that you can divide by 3 and 5 against same number, and you have the smaller term. We will talk about it. 3 and 5 are considered as prime numbers. 3 divided by 9, we know about that. 3 is 3 times 1, 9 is 3 times 3. Divide both of them by 3, bam. 6 divided by 64 is going to be a little bit challenging. 6 divided by 64. 6 contains 2 and 3. What about 64? Can you think any two numbers you can multiply them together? Obviously one of them is 2. What is the next number? The next number could be 32. Is that so? So okay, it means that right now, for the beginning of step, again, remember, baby steps. Try not to start from the big numbers, just the small numbers. Most of the time, 2, 3, and 5s are the answer. 6 divided by 2, this guy divided by 2. I do have 3, I do have 32. Can I do more? No, this is the lowest terms. Why? Because there's no number that you can divide by 3 and 32 at the same time. And after that, you don't have any problem with the fraction, with the division. You obviously have a problem. So 12 and 32, I cannot do it. Why is that? Because, I'm sorry, 13 and 32. Can you think about a number that you can divide 13 by that specific number, at the same time 32 by that specific number, and you don't you have some kind of even division? No, you don't have. So this guy is dead end. You cannot reduce this one to the smaller parts. That's it. 3248. Oh, this is a little bit challenging. Why 32.40 is a little bit challenging? Because think about the smallest number that these two numbers can be divided by that without any remainder. Obviously, it's 2, right? 3248. Just quick hint. Whenever you see a number that has even number on the units, I mean on the right part, 2, 4, 6, 8, you obviously 100% you can divide that number by 2. 32, 48, 16, 76, 32, 64. Doesn't matter. You can divide them by 2. Okay, let's go. 32 divided by 2, 16. 48 divided by 2, 32. Can I do more? Yes, I can. 16 divided by 2, 8. 32 divided by 2, 16. Can I do it more? Yes, I can. This guy divided by 2 is going to be 4. This guy divided by 2, 8. Can I do more? Yes, I can. Divided by 2, 2. Can I more? 4. Can I do it? Yes, I can. 1 and 2. So my final answer is 1 over 2. So at this point, you see that the sum of the answer is divided by 8. At this point, I do have 8 over 16. In order to reduce the number of steps, I divide it by a bigger number. Try not to do that. Only keep to the small numbers. 2, 3, 5, sometimes 7. Try to only keep to that, okay? Baby step. I know, it takes some time, but believe me, after years of experience, I know there are all the time, there's room for problems and mistakes. Try to reduce those mistakes by reducing your steps. Make them shorter as much as possible. 16 and 76. Is there any number? Obviously 2. I do have 6. I do have 76. Divided by 2 would be 8 divided by 38. Can I still work on that? Yes. 8 and 38. Both of them are even number. Divided by 2, 4 and 19. Can I still do that? No. So 4 divided by 19 is my lowest term. Simplest step. So common denominator. What does that mean? In the future, we will learn that if you want to do the addition or subtraction of two fractions, we need to find what? We need to find the common denominator. What does that supposed to mean? It means that you imagine that you have 1 over 4 plus 3 over 2. And if I ask you to do this, some kind of addition, you cannot do that unless you do have two fractions or more that they do have the same number as the denominator. This is something that we call as a common denominator, okay? So right now, maybe you think that, okay, how I can find it? And is there any easier way? I will answer to both of them. The first one is about the common denominator. What does that mean? If you have two or more than two fractions, and if you find the denominator that is going to be common for all of them, what does it mean by common? The common means that you find a denominator, for example, let's call it a CD. And if you divide this CD by each of those fractions, by each of the denominators, for example, this was 4 and 2, you don't have any remainder. You do have a perfect division without any remainder. We are trying to find that number. So I do have, for example, at this point, I do have 4 fractions. At this point, I do have 4 fractions. All of them are the same. This is something that we call as a common denominator. Simple. I do have this number of fractions. I have to find a number that if I do this process to them, there's no problem, right? How I can do it? Easy. Just multiply all of those denominators together. 6 by 8, 6 by 8, the answer by 9, the answer by 12, the answer by 18, 24, 36. That is a very, very big number. I know it's 80 million, 6,000, 2,100, 500, 6,000. That's a very big number, right? So, but that is the right answer, okay? That is the right answer. But maybe some of you would say that, is there any simple way that I can do that? Because obviously it's not going to be the one and it's going to be so messy. I said that, yeah, sure it is. This is something that we call as the least common denominator, or LCD. What is LCD? The smaller number into which denominators of a group of 2 or more fractions will divide evenly. It means that you can do the division without any problem, without doing all of these steps. Is there any way? Yes, it is. So let's talk about it. The very first thing that we have to know about the least common denominator is the way that we can find it. The way that you can find it is to find the lowest prime factor. So at this point, we do have 2 terms that we are not familiar with, prime and factor. What does it mean by a prime? So prime number is a number that if you some kind of have it, the only 2 numbers that this specific number can be divided by them without having any remainder is the number itself and 1. See that? Okay. What does that mean? Let's see. I will tell you 2 is a prime number. Let's just go back to the definition. Prime number is a number that is going to only can be divided. This is the only number that you only can divide that one by itself and 1. 2 can be divided by 2. Check. 2 divided by 1. Check. There's no number. No, that's a prime number. 3 only by 3. Only by 1. Check. 4. No. 4 can be divided by itself. That is good. can be divided by 1. That is good, but it doesn't necessarily mean that these are only 2 numbers. I still have another 2. So no. This is not a prime number. 5, prime number, check. 5, 1, check. 6 is prime number. No. You can divide it by 6. You can divide it by 2. You can divide it by 3. You can divide it by 1. Ooh, that's a whole package. I don't like it. It's not a prime number. So prime number, again, is a number that you only can divide it by itself or 1 without any remainder. So this is the terminology that we have about the prime. What is factors? So you remember that when we try to somehow show that, for example, 6 as 2 multiplied by 3, each of these smaller chunks that we can multiply them together in order to have the bigger number is going to be considered as factors. What does it mean by prime factors? Means that these factors only can be prime numbers. 2, 3, 5, 7, 11, 13. Try to remember these. What about 8? I either can write it down as 4 by 2 or 2 by 2 by 2. Which of these one I prefer? I prefer the last one. Why? Because I need the prime factor. I'm going to use them. So right now we find the prime factors, but what does it mean by lowest prime factors? It means that at this point, I just divide all of those things, of all of some kind of those numbers into the prime factor. The lowest one, 2, 3, 5, and some kind of 11. It means that I do have the whole package. How can I use it? The most number of times any single factors appears in a set is multiplied by the most number of times any other factor appears. Imagine at this point, I do have a whole package. 1 over 6, 3 over 8, 2 over 9, 5 over 12, and etc. And at this point, I'm trying to do what? I'm trying to find the LCD. So I have to divide them down into smaller numbers or into prime numbers, 2 and 3. I do have it by 2 and 2. I do have it 3, 3, 2, 3, 2, 2, 3, 3, 3, and etc. Find the number that is the most repeated one. What is the most repeated number that you have as a prime factor? It's 2. How many times is it repeated? 3 times. Keep it. What about other prime factors? Because again, each of those prime factors matters. What about 3? Multiply some kind of, we had it for only 2 times. 3 by 3. Keep it. After that, multiply those 2 together. If you do the multiplication, you do have a number. At this point, it's 72. 72, if you divide that number by 2, if you divide that number by 6, 8, 9, 12, 18, 24, and 36, you don't have any remainder. That is your least common denominator. Let's see some examples. 1 over 6, 1 over 8, 1 over 12. Some kind of divided into smaller chunks. 6 is 2 times 3. 8, 2 times 2 times 2 times 2. 12, 2 times 3 times 2. What is the prime numbers? 2 and 3. How many times? What is the most repeated amount of number? The amount of times that 2 is repeated. 2 repeated 3 times. Keep it. What about 3? Only 1 time. Keep it. Multiply them together. You have 24. Remember, it doesn't necessarily mean that your number should be repeated only in some kind of one whole number. At this point, for instance, let me just go back to another example. At this point, the most repeated time that I have, it happens for 3 parts. 1, 3 by 3. 1, 3 by 3 over here, which is part of another number. Another one, 3 by 3, which is part of another number. Right? It doesn't matter. It's in for the whole number, or it's part of another number. Keep it that way. So 1 over 12, 1 over 16, 1 over 24. How can I have it? 12, 4 times, it would be 4 times 3. Can I divide it down into small numbers? Yes, you can. 2 times 2 times 3. 16, 2 by itself 4 times. 24, 3 times 2, which is multiplied by itself 8 times. How many different kind of prime numbers do I have? 2 and 3. How many times 2 repeated? It's not 1 time repeated 2 times, 1 4 times, 1 3. Which one is the biggest? 4. What about 3? It repeated only once. Keep it that way. This one, multiply them together, and you have it. And the same scenario over here. So right now, I found the least common denominator. Why I'm trying to find that? Because again, I'm going to eat 2 birds with 1 stone. The first one is that I'm trying to make all of those fractions the same with their denominator. And the next point is that I'm trying to do this in a simplest form. I'm not trying to just blindly multiply all of the numbers together. Obviously, I'm not trying to do that. I'm just doing it by the best way it is. Because I'm lazy, I'm trying to find the best way. I'm trying to find the shortest way. So let's move to the next part about reducing to LCD. So obviously we found out that the least common denominator is the number that I like. Why? Because I can divide that specific number by all of those denominators and make sure there is no remainder. But here's the question that I found this number, but how I can convert those fractions to this one? Again, remember, when we're talking about the least common denominator, the one thing that you have to focus on is the denominator. This number is going to be represented as your denominator. It means that I have to find a way to convert my 1 over 6 to a fraction that its denominator is 72, but here's the question, what is the numerator? 3 over 8, the same thing. 2 over 9, the same thing, till the end. The very, very, very good way that you can do that is that you can find a number that your some kind of main denominator is just multiplied by in order to reach to the new fraction. For instance, at this point, I do have 1 over 6, and I would like to convert it to question mark over 72. So I know if I would like to convert one fraction into another, I have to make sure that nothing would change. 1 over 6 multiplied by 1 is equals 1 over 6. 1 over 6 multiplied by 2 is equals to 2 divided by 12. So I will talk about the multiplication, don't worry. But at this point, let me give you a hint. When you have the multiplication of fractions, numerator by numerator, denominator by denominator. Cool? So 1 over 2 is just 2. 6 times 2 is just 12 itself. Is there any difference between 2 over 12 and 1 over 6? No. Remember, when you convert the fractions together, there shouldn't be any kind of change in the question itself. If you just use the 1 over 6 in your calculator, if you use the 2 over 12 in your calculator, both of them have the same answer together. Cool? Okay. So let's do it. Let's convert all of those numbers into the one that we just like. So 1 over 6, I would like to convert it to question mark into 72. Remember, if I want to do that, I have to multiply the numerator and denominator by the same number. What is the number that I can multiply by 6 and I do have 72? That's exactly, that number is 12. What is the number that if I multiply it by some kind of... So right now, I do have the 12, and I have to do the same thing with the numerator. So 12 is my question mark. 12 divided by 72 for sure is 1 over 6. Why? Because if I do this backward, divided by 12, if I do this backward, I still have 1 over 6. Let's look at other numbers. 3 divided by 8. What is the number that if I multiply by 8 is going to be 72? That number is 9. Obviously, you can find it like that. So if that number is 9, and if I would like to convert this number to question mark into 72, this number, or 8, was just multiplied by 9. What about 3? This guy could also be multiplied by 9, which is 27. Do the same thing for all of them. 16 by 72, 13 by 72. Why am I trying to do that? Because in the future, you would see that if you want to do any addition and subtraction, you have to have the least common denominator, or at least the common denominator to do that one. So let's see a couple of examples. Okay, let's see the examples. So right now, I do have my some kind of LCD, and first of all, I have to find it obviously, and after that, convert all of those fractions to the least common denominator. So let's look at it. 6, 8, 12. Fast, 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 fast. 6 is 2 multiplied by 3, easy. 8 is multiplication of 2, 3 times by itself, easy. 12 is 4 times by 3, that's not right, because 12 is actually 2 by 3 by 2. Remember, we are talking about prime numbers, right? So I do have them, and after that, I would like to find the least common denominator. How I can find that? Remember, the least common denominator, I have to look at the prime numbers. 2, how many times 2 repeated by itself? 1 time, 2 times, 3 times. Which one of them I'm going to pick? I'm going to pick the biggest one. I'm going to pick the 3 times. Keep it. What about 3? Only 1 time. Keep it. 2 by 3, 24. Nice. I do have the least common denominator. So what can I do right now? Again, remember the LCD is the number that if you divide that one by all of those denominators, 6, 8, and 12, you'll have a perfect division. So I would like to convert 1 over 6 to what? To question mark divided by 24. What is the number that if you multiply by 24 by itself by 6, oh my god, by 6 you're going to get 24. That number is 4. What is the number that if you do that the same thing? Again, that's right, that should be 4. Do this multiplication by fraction, by some kind of denominator, you have to do the same thing for the numerator. 1 by 4, 4 divided by 4, bam, I got it. What about 1 over 8? I have to convert it to what? I have to convert it to question mark divided by 24. What is the number that if you multiply by 8 would be 24? Easy, 3. What about this one? 3, easy, 3 divided by 24. 1 over 12, the same thing, it would be 2 divided by 24, and that's it. Let's just keep it that way right now. Keep it, I will talk about it then. So, what about other numbers? 12, 16, 24. Simple, simple, simple. 12 is 2 times 2 times 3. When you do these things, try not to look at the answer. Try to just think about it by yourself, and after that, look at the answer. 16, 2 by 2 by 2 by 2. Easy. 24. It is 12 times 2. Now, it's not right. It is 2 times 2 times 2 times 3. Again, remember, I need the prime numbers, I have to find the smallest one. So right now, I do have two prime numbers, 2 and 3. What is the most repeated time of 2? It is 4 times, which is over here. What about other parts? I do have it at 3. So just multiply them together, and after that you have 48. So what about 12? 12, in order to convert it to 48, needs 4. So it means that I have to multiply by 1 by 4. So I do have it as what? 4 divided by 48. What about 1 over 16? The same scenario. What is the number that if I multiply by 16 is going to give me 48? That is 3. So multiply 1 by 3. 3 over 48 and 1 over 24, same thing. I know you can do the last one. So without further ado, let's move to the next part.